Hello everyone, my name is Hisham. I'm the owner of Clemson Aeronautics. We are located in Seneca, South Carolina, right next to Clemson. That's why it's called Clemson Aeronautics. And we make the riveting and dimpling system that is used in the experimental aircraft market. And to order one of our systems, you got to determine which one it is. So you can go to our website here, clemsonaeronautics.com, and when you want to know more information or you want to order the system, you can call me on my cell phone number at any time, and we can arrange to build one of the systems to your specification as far as what you want and options and so forth. This is as simple as it gets. I'd like to remind everybody that this is not an instruction video on how to build an experimental airplane. It is more like just an introduction to what I do here, building my own RV-14A in my shop. And the whole point of building that RV-14 is to demonstrate our tools. So while building your airplane, you have to refer to your manual on how to do specific things and so forth. This video is made specifically to sum up all what I have done to finish building my vertical stabilizer. Things to watch for that would make your life a little bit easier. One of the things that you need to be doing is looking ahead a little bit, and what I mean by that is the rudder. A mistake that I've done, which is not ordering the double-sided glue from 3M that you're gonna need on the rudder and other places too, like the elevator and stuff. So ordering that, it might take a while for it to arrive. Luckily, I found it on McMaster Car, because this is like one of my suppliers. So by accident I got onto the website and I found the tape, and surprisingly it was cheaper than anywhere else. Let me stick that up there so you guys can see it. McMaster Car, and I believe there's a phone number too, but you can order it from the website. And luckily it was in Georgia, and they sent it to me. I ordered the 1/2-inch one. It came right away. It was terrific. So now I have that ready for my rudder, and the other project is 60 yards, and it was like $20 or $21. So, but the shipping was 10, so I wound up paying like $30 for the whole thing delivered to my house, which is a lot cheaper than anywhere else. Now, the rivet gun. It's a number 3. Obviously, you guys can tell where I got that. Swivel joint. I was afraid to go cheap with that. But I have a friend of mine that's an AMPIA, and he's been in this business for quite some time, and he built some Oshkosh winning airplanes. I really respect his opinion. He said, just buy the cheap one and see what happens. What's the worst that can happen? So, and I had nowhere to go that day. I'm in Seneca, South Carolina. It's not like, you know, something close by here, and I needed to rivet that day. So I went ahead and bought this from Harbor Freight Aerospace, and I've installed it on my rivet gun, and surprisingly it was amazing. It was great. So it worked out great for me. You might want to try it. Things to watch for: rivet gun. You need to oil it up. Put a few drops of oil. It's supposed to be like a teaspoon of oil every day before you start riveting with it. If you're going to store it for a long time, you need to, when you finish using it, put a few drops of oil in there. Just run it a couple of times and put it in a plastic bag or something to store it. I got this regulator to regulate the pressure. I never really installed it, and you can tell here, this is also from Harbor Freight Aerospace, and it works well. And I mean, you can see the thing on it is I adjusted it to 25 psi to do the riveting on the number 3 rivet on the vertical stabilizer, and it worked great. So I didn't need any more than that. I didn't need any one of those because I just have that on my airline, so it worked great. Calipers. I think calipers is the way to go. When you're riveting and you're creating a shop head, I think the easiest way to figure out whether you got a good shop head or not is the use of a caliper. If you go to your manual that you got from Vans on page 5-4, on the left side, it shows you the dimensions of a shop head. Height is half the rivet diameter. The diameter of the shop head is 1.5 times the rivet diameter. So if you calculate, for instance, the shop head of a -3 rivet, so it is 0.0935 multiplied by 1.5. This is what you got. Now, go no-go gauge. I'm sure you guys are familiar with that. If you have a rivet head that you squeezed and it is 142,000, 143,000, you're gonna put this on there and it's gonna go right through. Why? Because the diameter of this hole is 145,000. So anything that's 145,000 or under, this shop head will go through it. Although it was a good shop head. So you need to use the caliper to see how close you are. Even if you want, or you're bound and determined to get this not go on the shop head, so you need to squeeze some more, and now you're at 143,000, but you don't know it. And you play with the pin on your squeezer too much, you squeeze it too much, that is not gonna, you cannot unsqueeze it. Or if you're using your rivet gun, and now the gun could slip and ruin your, and it's not necessary. If you're 142 or 143 thousandths, you don't need to, especially if you're using the rivet gun. If it gets to that, I think I should leave it alone. It looks good, leave it alone. But the caliper here tells me how close. At the beginning, you're gonna find yourself getting the calculator and punching numbers. This is a -3 rivet. It's 93,500 times 1.5, and the shop head now is 135,000, 138,000. So how much more do I squeeze and all that stuff? At the beginning, sure. But after that, you're gonna memorize all these numbers. You use the caliper, you're gonna know, I'm gonna do a quarter turn on that, and you squeeze, and it's right on. Okay, so this might be a little bit hassle at the first few times, but after that, it gets a lot easier, and you're gonna thank me for it. Creating a dimple in the skin of your aircraft. when you put the rivet in there, if the head of the rivet is lower than the skin, you have a problem. If it's too much lower, especially, you have a problem. Because once you start squeezing or riveting, that head will drop down and there will be a gap between the funnel shape of your head and the dimple that you created in the first place. Now you have an issue. I had an issue with my -4 rivets, but this is a machine shop and I created something special to deal with this issue. I cannot go into it now, but this issue you have to be careful with. When you dimple your skin, the final shape of that dimple is 100% because of your dimpling die. So be careful and choose something that people say it's good. The set that I got, I am not convinced it's good, and I have to do something about it, but and I don't know what. But again, this is a machine shop and I made it work because I have the technology here to make special tooling for myself. So please be careful with that. When I started this in my first video, I talked about using reamer versus a drill. And I used the 095 reamer on all the -3 rivets. I would like to report to you that my experiment worked out great for me. So I advise you to use a reamer, not a drill, to final drill anything. And by the way, I heard the gentleman from Vans RV himself saying that, okay? Because reamer gives you a round hole. Drill, it will be more like a triangle kind of shape if you blow it up in a picture, and you're gonna see that. Reamer is the best way to go when it comes to that. So even when I'm doing match drilling, I use the drill like the first thing that you do is match drill on the front spar. So what I did there, I got a 3/32 drill, 0.0935 drill, and I match drill that first. Then I put a reamer through it, which is 0.95. If you like to go with the 0.98 size, put a reamer 0.98 in there, but started with a smaller drill, which is the 3/32. It will certainly be much better for you than using a drill. Now, this is a touchy subject because people don't like to be told what to do, and I'm not really telling you what to do. I'm telling you be careful with this, because simple tools like a grinder can hurt you, really can. And I have said it in another video earlier, one of the videos that I've done, and you can see, you can go back and look at this video where I was buffing something and these tassels got pretty close to the wheel. If it had grabbed and pulled me into it, it would have been devastating. Be careful with your clothes while you're working with rotating tools. The first thing that I learned, of course, when I was studying manufacturing and CNC machining, and I did a lot of manual machining, a lot of it, and we had to be careful with that. We weren't even allowed to wear gloves when we were doing machining, because gloves can get caught and it will pull you right into the machine. So I should have known better not to do this. The least I should have done is put this inside. That's one thing about the grinder. Second thing about the grinder, when you are buffing something, don't go like this up to it. And I was just watching a video yesterday. There is a guy, I think is this of Flight Chops or something like that, the guy with the... But anyhow, they are building an RV-14 also. And one of the experienced guys in the team building that RV-14 had one of the ribs, and it looked like a flap rib or ailerons, or maybe the elevator, I don't know. Maybe it could be the elevator. But anyhow, he put it like this in the grinder, and the grinder grabbed, and it pushed it in, threw it in his chest, and tossed it out, and bent it. I mean, there's no fixing that. They had to order another one. It's time to admit that I have done the same mistake before, and I should have known better. I should have known better. But you just don't tell me when you're just going at it and stuff. I mean, you should be going like this, the long part in, and you go up with it like that. And sometimes I would go and I would roll it up. When I roll it up like that, this is the point that it will grab and will push that towards me. And if it's something sharp, it could cut your hand. Be careful using the grinder. Another thing that you should be careful with the grinder is you should designate a buffing wheel for aluminum. Aluminum, you don't want to put iron into it. Iron rusts. So if you buff steel with it, then you come in and put aluminum in it, it will embed some of that steel into your aluminum, and later on it will rust. So my advice, you got a $30 or $40 grinder, and if you're gonna use a buffing wheel to do something with metal iron, other than aluminum, I mean, put 2 buffing wheels. One, is for aluminum, another one for the steel. So be careful, don't mix that up. It is important. The rear spar doubler is a pretty thick piece of aluminum, and you'll probably get it in banana shape, kind of curved, and it's very obvious. And in the manual, page 5-14 tells you to straighten out those thick parts before using it. And the method that they're talking about, putting it in a vise and preloading it and hitting it with a rubber hammer, I won't talk about that. I'll talk about what I learned at AMP school, is to use this. This is a slip roll former. My advice, if you know somebody that have one of those at EMP or something, or for whatever reason they have it, and you can use it, and be very, very careful not to bend it the other way. Also, that doubler have ridges on it. It's from punching it, and you'll find a really high, steep, high spot, and then be flat and steep, high spot. I think the best method to deal with this is with a nice file. Take those high tops off, make it level with the others with the file, then use a buffer to buff it out, buffing wheel. It will work out great. The part in the manual where it talks about the radius, the shape of the nose ribs, both the 705 and the 706, that is important. You really need to radius that and buff it out real nice. I've read on the internet where people ruined their skin while they're putting it on the skeleton, and it kinked it from the inside. Maybe not punctured, but it looks pretty ugly. So I'm pleased to say, because I buffed it out really and rounded out really nice, I have no issues whatsoever. Not one place that that I found on there that was kinked or pushed from the inside or anything. So please be careful with that. And the method that I used to put the skin, open it up and then set it down and so forth. And then the second time when I had the rear spar on there, it was wobbly and everything, but that because of the clicos, I think I should have been better prepared to put some 2x4s or something so the clicos won't be on the table, and use tape or something to tape something to make it more stable. The 706 rib, the two front holes, the two most forward holes, are pretty difficult to dimple using a squeezer. And those dies, it's not gonna go in there. There's no room. And by accident, I discovered the way to do it. And what happened, I got this this kit from Cleveland Aircraft Tools, and I've mentioned it in the video before when I was dimpling. And this portion of it that have the shape of the dimple, to me, I think the best way to do it, and it's easiest with the regular yoke that I got, is to have this from the inside, and I would tape it from the inside so it will hold it in front of the hole from the inside. And I would take this half of the die and put it through the hole. Now I have these lined up and everything perfect. Then I would bring my squeezer with the yoke. I put the yoke in the back of this just to hold it in place, but this would ensure that it is engaged correctly. So this from the inside then is taped, and here is the skin of the rib, and I would put this through the hole of the rib like this. It will be engaged. Then I would put my yoke on there and then slowly advance the squeezer pin to go right here, and then squeeze it. Then you pull it out and you got yourself a dimple. That is the easiest way that I found to do it right now, and I didn't even attempt to use this with a puller or anything. So that's how I did that. So I hope that helps somebody somewhere. Now the soldering iron. When I was trying to use the soldering iron to remove just a strip where the holes are on the skin, I had really a hard time with it, and it won't come off and won't cut correctly and all that stuff. And I discovered that I didn't let the soldering iron get hot enough. It really needs to be really hot, and I shouldn't move very fast. Now, of course, the hotter it is, the faster you move. And you can look at it and you can see it, you know, kind of bubbling while you're moving. But before you do so, you need to round the nose on that soldering iron or you're gonna scratch your skin. So buff it out real good, make it nice and round, and before you use it, and get it hot enough. Now, in the manual, in page 6-4, the note that is mentioned on the bottom left side, it says install AN 470 rivets with the manufacturer head on the aft surface for easier access to the skin to spar rivets. That is so true. That is so true. For a certain reason, I was gonna do it the opposite, but I thought, okay, those guys done this a lot, so they know that I need this space there, and I noticed that the holes kind of line up where the rivet right next to a hole in the side, so where I rivet the skin. So I did what they have in that note, and thank God I did, because riveting the skin to the rear spar, it gets really tight. So be careful. If they put a note in that, there is a good reason, and they were correct. So pay attention to these notes. Don't miss anything, and don't think like, oh, I mean, this is for the guys that don't know. I mean, I can do it this way or this way. Take their advice on that. They know what they're talking about. Now the clecos. I want to show you guys these two different clecos. Can you tell that the diameter of the ring on the tip there is different on both of those? Well, thank God most of my clecos are the smaller diameter. The larger diameter and the smaller diameter both leave a ring on the surface of the skin every time I use it. Which really is a very small ring, but at the same time the clad is only 2/1000 of an inch. 2/1000. So I'm scratching that clad pretty bad. So what is the solution? And of course, from now on, during my build, I'm gonna leave the blue protective covering on there. I'm not gonna cut a strip right where the holes are, then install a cleco on it. I am not gonna do that. I'm gonna leave the cover. Maybe not from the inside, I can remove the one from the inside, but from the outside, I'm gonna leave the cover before I put a cleco on there, so it won't leave a ring on the skin. That's one. As much as possible, if you're gonna use clecos, leave the protective cover on there. The other thing about clecos, I'm sure you guys are familiar with those. Now, when you're riveting the skin to the ribs, especially the 706, the one on top of the vertical stabilizer, you have to adjust the angle, and you might have adjusted it a little bit too much so it's bent inside. Before you rivet that, you need those to be flush, be against each other. Using these clecos are not gonna bring them against each other. It's a bit of a hassle. My advice to you is to use those to place them in the correct position. The holes line up perfectly. Then for every single hole, use these long ones, and you put them at an angle like this, okay, to pull both skins, the rib skin and the outer skin, together and have them touching really tight. The reason you pull them outside like that and you use the long ones is to give you room to go in with your squeezer to squeeze that rivet. You'll be very happy if you do that. And I use the protective tape, or that tape, the painter's tape, the purple one. It is much better. It doesn't stick to the rivet when I'm peeling it off. I peel it slow, but this one, slow or fast, you're leaving a part of it on the rivet head, so it's very aggravating. But this one peels off, and it protects the skin with the squeezer, okay, because the squeezer is going to leave a mark in there also. So using the tape and using these are going to help you quite a bit in your build when you're doing something on the edge. So this is a lesson for all of us, of course including me, for the rest of the build when we're riveting the ribs that's outside. Use these to make a good engagement between both surfaces. Now, as I mentioned earlier in the video, the riveting and dimpling system that we make here is our business, and we'd like to build one for everyone out there that's building an airplane. And I really truly believe it's going to make your life a lot easier. And you guys are going to see that in the rudder more so than this, because here, yes, I used it to do some riveting and stuff like that, and it was nice for the dash 4 rivets on the rear spar, and it's not supposed to be for the dash 4 rivet. Dash 4 rivet, when you use it, it spreads it out too far, so it doesn't squeeze the rivet before it flexes out too much. But in order for me to do that, I had to brace the machine in the middle. So halfway down the throat, I put 2 bars in there to hold it down, and I got all the dash 4 rivets squeezed. So it is originally made for the dash 3 rivets. It will do that with ease all day long, no problem, with a very high precision, every single rivet the same. When it comes to the dash 4, this is kind of the icing on the cake. This is kind of an extra thing. You can put a brace in that. That's why, I don't know if you guys notice or not, there is a series of holes on the side of the machine, on the top and in the bottom. So you can move that brace anywhere you want to. Okay, and this is kind of, I suspected that in the very beginning. That's why I put these holes when we were machining that on our CNC machine. So I think this feature, riveting the spars, the dash 4 rivets, and bracing, although I don't know what's in this manual and what I'm going to get into in the future, I'm just taking it one day at a time, just like any other builder. I'm not sure how many people out there that read the entire manual before they started the build, but I didn't read but the section I was doing. Now, I watched enough videos on YouTube and everything to know that I'm gonna need the double side. Actually, it's a glue. That's what it is. Okay, from 3M, basically clear. Thank God I got that far, and I ordered it and I got it so I can use it on the rudder. But you're gonna see the machine full action in the rudder, skin, stiffener, riveting. It's gonna be artwork. So, but I think looking in the future at the horizontal stabilizer, I think there's a little bit of riveting there and doublers and stuff like that, and a lot of it is dash 4 rivets. I think this machine is going to do a great job. Using the brace is no problem. It just doesn't take but a couple of minutes to brace it up and adjust it to do the riveting. And every rivet is the same. If you didn't see it riveting the doubler on the rear spar of the vertical stabilizer, please find the video on my channel and watch that. It will give you an idea of what it can do. And guys, this is my number right here. Call me. And if you have any questions, I'll be happy to answer any questions. I see the need for a no-hole yoke in my tool arsenal. I'm sure you guys understand by now that we have enough technology here to make that. So I am going to, as soon as I come to a point where I can stop a little bit and work on a side project like that to do it and test it in the project. If we need it quicker, we'll probably make it quicker. Thank you very much for watching the entire series for the vertical stabilizer, and I hope somebody benefited from that, especially looking ahead before you build what you're going into, tools that you're gonna need. Do get reamers, and it will do you some good. I hope you guys enjoyed our videos, and tomorrow we start on the rudder. Thanks guys for watching.